Hello guys, welcome back. Today in this video tutorial I will be taking a new proximity sensor, that is TMD2771. Now to have a better perspective regarding the sensor, let's visit the website, that is controleverything.com, and here we have to search for this particular sensor and let's see what we got else from that. And as you can see, it's an ambient light sensor with 16-bit proximity detection, and these are some of its more prominent features which you can see on my screen. You can also have the ability to purchase the sensor from this website from here. Further, I will be interfacing the sensor TMD2771 with a Raspberry Pi and a Java code, and let's move to resource tab, and here comes the Java code sample. Now you can download the Java code sample as a zip file from this very site, from here, just like that. Also, you can have the code from github.com, and the repository there is Control Everything Community. Now let's have a look over the hardware connections we need to set up, and let's proceed further. In the hardware section, first of all, the requirement is of a Raspberry Pi, which you are able to see on my screen, and these are the GPIO pins of the Raspberry Pi. Now this here is an I2C Shield. It's available on the website controleverything.com, and the real reason we are using is to make easy connections with other I2C devices. So gently place the I2C Shield over the GPIO pins of the Raspberry Pi and make a connection. Next, we require our sensor, that's a proximity and ambient light sensor TMD2771. Now this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and for the same reason to the I2C Shield. Now we require to power up our Raspberry Pi, and for that a micro USB cable comes handy. Now gently insert it over the power jack. Now the last part is to provide internet connection, and there are two mediums. First medium is Ethernet cable or a LAN cable, as you can see, and gently insert it over the Ethernet jack. The second part is a wireless USB nano adapter, which you are able to see on my screen. Now these are the final connections we need to set up our device with the sensor. Now what do we require is to have a look over the code, and let's interface it with that. Now in the interfacing part, what do we require is to have a look over the Java code, and to get that, log in to github.com, and here we have to search for the repository, that is Control Everything Community, and let's see our sensor, it's TMD2771, and here is the Java code. Now let's have a look over the instructions first. It says that we have to download and install Pi4j library on the Raspberry Pi, and the steps are provided on this very link. Let's open up this link for the reference, and let's see what are the instructions. As you can see, installation methods, commands are there to install Pi4j. Please note it down and do the installation carefully. After that, this is the command to compile, and this is to run the Java code on the sensor. Please do it carefully. Now open up the Java code. As you can see, it's a .java extension file. Now in the code, you notice that we have imported some of the Pi4j libraries, and we have created a public class named TMD2771. Then we have bus.getDevice, which will have the address of the sensor, that is 0x39. Now in the writing section part, we have selected enable register or with command register. It says that 0x00 or with 0xA0, and we have to send a command to set power on and proximity, wait, and ALS enabled, which goes for 0x0f. Then we have to select ALS time register 0x01 or with command register 0xA0, just like here, and we have to send a command for A time, that is 101 ms, and it's 0xdb. Then we have to select proximity time register having address 0x02 or with command register 0xA0, and we are sending a command for P time equal to 2.72 millisecond, max count equal to 1023, and it's 0xFF, just here. And next we are selecting a wait time register having address 0x03 or with command register 0xA0, and we are sending a command for W time, that is 2.72 ms, and it will be 0xFF, just like here. Then we are selecting a pulse count register having address 0x0 or with 0xA0, that's the command register, and we are sending a pulse count of 4, which will be 0x04. In the last command for the writing section, we are selecting the control register having address 0x0f or with command register 0xA0, and we are sending a command for 120 milliampere LED strength, proximity uses channel 1 diode, 1x P gain, 1x A gain, and it will be 0x20. So we are done with the writing command. Now what do we require is to read the data back, and we are reading 6 bytes of the data from the register 0x14, that is OR with command register, that is 0xA0, and it will be channel 0 channel 1 data along with the proximity data. After that, the conversion of the data takes place, and it has a lot of formulas and the conditions which are implied and clearly described in the data sheet for TMD2771. At the very end of our code, we have the output data on the screen to be displayed in the form of ambient light luminance and proximity of the device, which is in lux. As you can see, ambient light luminance. Now what do we require is to have a look over the practicality and see how the sensor responds and works. For the working environment, first of all, the step is to copy this entire code of the Java, as you can see on my screen. And after that, we have to open up the terminal for the Raspberry Pi. And here we have to create a new file, as you can see on my screen. .java will be the extension, and here paste the entire code, and after that we have to save it, and then this is the command for the compilation of the code, as you can see on my screen. .java, and here you go, it's successfully compiled. Now this is the command to run the Java code of the sensor TMD2771, and we have the ambient light luminance in lux and proximity of the device. As you can see, when I'm running the command, the values are almost constant and there is no major change. But when I place some object over the sensor, you can notice ambient light luminance decreases, but proximity of the device increases. As I closing the object to the sensor, it will be highest value for the proximity 1023, and ambient light luminance is almost minimum. But instead, when I bring a light source near the sensor and run the command, you can notice the increase in ambient light luminance, and there is a change in proximity of the device, just like that. So this is how the sensor works. Now what do we require is to have a look over the applications and the benefits of the sensor. The TMD2771 family of devices provides digital ambient light sensing ALS, a complete proximity detection system and digital interface logic in a single 8-pin package. The proximity detector includes a digital proximity sensor, LED driver and IR LED, which are trimmed to eliminate the need for end equipment calibration due to component variations. Excellent background light rejection allows the device to operate in environments from sunlight to dark rooms. These features make it very useful for applications like cell phone backlight dimming, cell phone touchscreen disable, notebook monitor security, automatic speakerphone enable, and a lot many. This sensor can be purchased from the website controleverything.com, and you can have the code from the source tab, and after that you can download the code as a zip file. You can also have the code from github.com, and the repository there is Control Everything Community. In the end, I would make it clear that for any further queries, you can reach us on controleverything.com, and to post your comments, you can post on the community page. For blogs and articles which are relevant to this sensor and the code and the video, you can go to instructables.com, and to subscribe more video tutorials just like this, you can have a look upon our YouTube channel. I hope you enjoyed this video, and thanks a lot for watching.